Welcome to today's lesson. I am Siamasaka Kirendens. So I'm going to take you through actually a revision in chemistry where we're going to solve actually examination questions. And so we go to the lesson right away. Well, we are going to look at solved division questions. We are going to solve them really. And as I've indicated here, if ever there are some people who want to know for examinations, you can actually contact me using the WhatsApp number +260 977 419949. That's my WhatsApp number. And so basically we'll look at the periodic table. And this periodic table, we'll use it actually to answer questions. So the first part of the question is as follows. Element T and X are respectively represented by the symbols T, and there is a number there on top, 24, and down 12, and X, 14 on top and down 7 respectively. What do the numbers 12 and 7 stand for? So in these elements, T and X, what do the numbers 12 and 7 stand for? Actually, these numbers for A, actually they stand for the atomic number. So the atomic number is also the same as the number of protons in an element, number of protons. It's the same really. So that is the representation of 12 and 7. What do the numbers 24 and 14 stand for? They stand for actually B is the mass number. It's the mass number, or it can also be known as the nucleon number. So the nucleon number is the same as the mass number of the element. So we have really solved part A and B. So we go to part C, give the period of the element T and X. So for you to be able to give the period of the element T and X, the easiest is actually to write the electron configuration. So the electron configuration of T, which has actually the atomic number, which is 12. So the electronic configuration for this one actually would be, in the first shell, there will be 2 electrons. And in the second shell, actually there will be 8 electrons. And the third shell, there will be 2 electrons. Therefore, T is in period 3. So what it means is that the number of shells actually gives the period in which that element is. For X, with actually the atomic number, which is actually 7, so this one, the electron configuration would be 2, 5. So in the first shell, we are going to have 2 electrons, and the second shell, there will be actually 5 electrons, making them 7. And therefore, X is in period actually 2. And so from the periodic table here, we were aware that these are the periods. So this one is helium and hydrogen are in period 1, and then these would be in period 2, and these would be in period actually 3, depending on the number of shells. Okay. So we have done this one. Give the group of the element T and X. So the group actually look at the number of valence electrons, the number of electrons in the outermost shell. So you notice that here we said actually T, the electron configuration was 2 because it has 12, 8, and 2. Therefore, the number of electrons in the outermost shell is 2. Therefore, T is in group 2. We normally use the Roman numerals. And for X, with the electron configuration of actually, because the atomic number here is 7, which we said it is actually 2 electrons in the first shell and 5 in the second shell. And therefore, X is in group 5. So, in other words, the group number is the number of electrons in the outermost shell. So the element will be placed in a group based on the number of electrons in the outermost shell. While for the period, it's the number of shells that the element has, which places it in that period on the periodic table. So which element, T or X, is a non-metal? Number E. You remember we said that T has actually 12 electrons, which gives the electronic configuration to be 2, 8 in the second shell, and 2. So non-metals actually, for them to be stable, they gain electrons. So for this one, T is a metal because it actually loses electrons. T is a metal because it loses electrons. To be stable. So it will lose these 2 electrons. It is easier for it to lose 2 electrons than to gain 6 more to make them 8. While X, we said it has 7 electrons, or we said the atomic number is actually 7, and therefore its electron configuration is 2, 5. So what this means is that it is easier for it to gain 3 to make them 8 here than to lose the 5. Therefore, X is a non-metal because it gains. So it will gain 3 more. It gains electrons. To be stable. So for it to be stable, it is easier for it actually to gain 3 electrons so that the outermost shell can have actually 8 electrons. What common name is given to group 1 and group 7? Oh, actually, we have omitted number F. Identify element T and X and give the electron configuration of the T and X. Actually, we have already given the electron configuration. So T with the actually 12 as the atomic number. This is actually, if you go to the periodic table, you will notice that actually this is the magnesium. This is magnesium. So T is magnesium. While X with the atomic number 5 actually is nitrogen. If you check on the periodic table, you will notice that actually the element with the atomic number 7 is nitrogen. And so we go now. The electron configuration, we have already written it several times. So what common name is given to group 7 and group 1? So number G, actually, group 1 elements are also known as alkali metals, are alkali metals. While group 7 elements are halogens. They are known as halogens. Write a balanced chemical reaction of potassium. Chemical reaction of potassium with water. When potassium actually reacts with water, which is actually H. So potassium, which is a solid, reacting with the water, which is a liquid, you are going to form potassium hydroxide, which is aqueous, plus hydrogen will be given out as a gas. So really, when an alkali metal reacts with water, you form a hydroxide and hydrogen is produced. So balancing this one, actually you notice that you need to have 2 atoms of potassium. Therefore here you put 2, meaning that you have 2 atoms of potassium this side and 2 atoms of potassium on the other side. And for hydrogen, you have 4 atoms here, and this side you have 2 plus 4, and oxygen you have actually 2 on both sides. So this is the balanced chemical equation. How do the reaction of lithium with water compare with the reaction of potassium with the water, and give a reason for the differences in the reactions? Actually, lithium will also react with water, which is a liquid, this is a solid, to form lithium hydroxide, which is aqueous plus hydrogen gas. And we can balance this equation the way we did the other one. But this reaction would be slow. Then compared to the one for potassium, when it reacts with the water, which is a liquid, you form potassium hydroxide, which is aqueous, plus actually hydrogen gas. So balancing this equation actually gives us that. But this reaction would be actually faster. So the reason is that actually when you write the electron configuration for lithium with atomic number 3, you are going to get 2 electrons in the first shell and 1 electron in the second shell. While for potassium, the atomic number is 19. Atomic number is actually 19. So potassium, the atomic number is 19, meaning that the electron configuration will be 2, 8, 8, 1. So you notice that here, the electron which is lost in lithium is nearer than nucleus, which is actually containing the protons which are positive. Therefore, the electron in lithium is actually attracted more to the nucleus. So the lost electron in lithium is attracted more to the nucleus, which has actually positive protons. Than that of actually potassium, which is further away because it has actually 4 shells. So it is easier to lose the electron which is very far from the nucleus than the one which is nearer to the nucleus. And therefore, the reaction for potassium would be actually faster than the reaction for lithium with water. What is the state of chlorine and Aldine at room temperature? Actually, chlorine is a gas. It's a gas at room temperature. While actually iodine is a solid at room temperature. So at room temperature, actually chlorine and fluorine are gases, while bromine is actually a liquid at room temperature. Then iodine is actually a solid. That's how actually the halogens or group 7 elements are. Write the chemical reactions of the following if they are possible to take place. Potassium chloride reacting with the bromine. So they are saying potassium chloride reacting with the bromine. What do you get? Actually, this reaction will not take place because chlorine is more reactive than bromine. Therefore, bromine cannot displace chlorine. And therefore, this reaction cannot actually take place. The reaction cannot take place because bromine cannot displace chlorine. While the reaction of potassium iodide with chlorine potassium iodide plus chlorine. Actually, you are going to get potassium chloride plus iodine. And balancing this one, we're going to have here 2, and there you're going to have 2. It is possible because it is possible because actually chlorine can replace iodine, because actually chlorine is more reactive than iodine, and therefore it can easily displace it. And so I thought today we can look at these questions which normally come in an exam. And so we'll continue looking at the periodic table and look at several other questions which we can suspect that actually they can come in an exam or in an examination. And therefore, I thank you for actually listening.